Hi there, welcome back. Well, we're back to the Telefunken Gavotte 55, and when I left off in the last video, we had a problem with that FM switch. It was very intermittent, and I have found the solution. It's really not what I expected. I think perhaps it was a combination of things, but what we've got here now, it's fine. So what was it? Well, this is where it gets weird. I did more cleaning on there, and then I did more cleaning on there, and guess what I did then? I did more cleaning on there, and it was doing exactly the same thing. Then I found something strange. When I lifted this thing up, 90 degrees, this thing was working perfectly. That's when I thought perhaps this has to do with strain, in other words, with twisting of that switch mechanism. Because when I lift this up 90 degrees and put it sort of on its back, the forces on the chassis change, and therefore something was causing that to come into operation. When I put it down where it's supposed to be, like this, the strains were different. So what I decided to do is look at the switches, or rather look at the screws that actually screwed that switching system to the chassis, and see if any of them were loose. Then I found that guy. That is a screw that's going down through the chassis into the switch mechanism. It's the one that pulls up, in other words, connects the switch mechanism to the chassis. And this is the one closest to the FM switch. And I tried to tighten it, it wouldn't go. I tried to loosen it somewhat, and this thing started working suddenly. So I tightened it again, and it was giving me the same fault. Loosened it again, and I don't mean loose, I mean just sort of a quarter turn. And this thing's working perfectly now. And I can now move it all over, twist it, basically flip this around, and it just keeps working. So I think that was the problem. I think at some point the chassis obviously warps a little bit, and it was putting too much strain on the switches inside the switch mechanism, and it was forcing it, depending on which position the chassis was in and the strains within the chassis, forcing it to break contact there, which is definitely not what I expected. I mean, I was dreading having to remove that whole mechanism, because believe me, it's not simple. It's really, really complicated. And I'm so glad that that is not going to be necessary. But obviously, keep testing it. We'll see if this thing continues to work, and if it does, then it's solved. And while on the subject that we covered yesterday, I'm putting this on pickup just to see what hum we've got. This thing is at maximum volume, and I can hear a very, very slight hum on the speaker if I get really close to it, but the hum is gone, which is fabulous. Right. Let's carry on. Now the next obvious step is the FM alignment, and I'm going to do it my way. This thing is receiving, so the IF seems to be fairly okay. What they tell you to do is they tell you to align those two. It's that one there and the one below that, by sending the signal into the EF89, the grid of the EF89. So basically what it means is anything before that doesn't matter. You feed the signal in here and you tune it from there forward towards the audio. Then what you do is you come one step further and you feed it to the CH81, which is before this guy, and you adjust that one there and the one below, and you maximize that, which means that you've cleared the path over here. You now clear the path over there. And then you go one step further and you feed it just loosely coupled. You basically take a winding of a coil, or you just take a wire and wrap it around here a couple of times. And you feed your signal to that. That's lightly coupling to the CC85. And then that sort of gets thrown through, pushed through, and you adjust that one there and the one below that to allow the 10.7 megahertz, which is what the IF is, to go through from there to there. So you basically clear the entire path. Now, because I know that it's going through, I'm just trying to optimize it. I'm going to go straight to putting it loosely coupled around the ECC85, and then I'm going to do that one there and the bottom one, that one there in the bottom one, that one there in the bottom one, and we'll have the IF aligned. And the way you align this for these two, top and bottom, these two, top and bottom, and this one at the top, is you go for maximum negative DC voltage across that cap on the underside, the ratio detector cap. You put a voltmeter on there and you align it till you get the maximum voltage from feeding a 10.7 megahertz carrier in here, unmodulated. Just a 10.7 megahertz wave, a sine wave. You basically set its amplitude depending on what signal you're getting there. You don't want to get too big a signal or the AGC will kick in, but I'll show you how to do that, and you measure the voltage across the capacitor. The way to align the final stage, which is the slope detector, is you actually measure the current between a given point and another given point and you null it out. The other way to do that is you put a scope on the output and you see when you get the best sine wave, and you have to send a frequency modulated signal in here. So instead of 10.7 unmodulated, you send a 10.7 megahertz carrier signal on here, and you put a audio tone modulated on it. If your signal generator can do that, most of them can. Let's say you put a 1 kilohertz signal, you'll then be able to see that 1 kilohertz on your speakers, and you put that on the scope, and you adjust that final one till you get the least distortion. In other words, the sine wave as perfect as possible. I actually prefer that. It's a bit more visual and a lot more intuitive, and I prefer to use it that way, which is probably the way I'm going to do. So I'm going to set everything up and I'll show you the procedure as I go along. So with the FM alignment, what we're trying to do here is this. This is the schematic looking at the radio from the back. That's the FM can. That's the second IF. That's the first IF. Now, obviously, this is the end, this is the middle, this is the beginning where the signal starts. So we have these two, 112 and 111, inside the FM front end can. We have 18 and 19, which is the first IF. These two have to be optimized or tweaked for maximum performance, for peak. And then we've got these two, which is 24 and 25. 24 is peaked. I'll explain what that is in a second. And 25 is the one where you get the best slope on the thing so that you get no distortion. Now, knowing where these are is very important, because if you get the wrong ones, you're messing with the AM. And we don't want to do that because we've already optimized the AM. Now, where we're going to be measuring is across this capacitor. This is that ratio, the detector capacitor. And we are measuring a negative voltage, but we can change the polarity on the meter, so it's not a problem. So this one end of the meter I'm going to put to chassis, which is just anywhere metal. And this one goes to the other end of that capacitor, so it goes to here. So that is set up already. And we are now going to be tweaking. You have to look down there. There's one there. There's one there. So I'll be going in. I won't show you myself going in, but you'll see the meter and see what the result is. That's on the underside, and obviously we've got the two on the top. I've also talked about lightly coupling the signal to the ECC85. That's it there. Lightly coupling is just, I make a tube of paper, wrap 5 or 6 coils of wire on there, and there's my coil, and then I just fit it over the top there. Nothing shorts, and my signal generator with the 10.7 megahertz signal, with or without modulation, goes in there. Now if I turn the volume up, I've got a modulated signal on there of, I think it's 600 hertz. You can hear it. It's a weak signal. You can hear it. Now if I turn off the modulation, all I've got is the carrier. And it's still giving me, what, about 1 volt? So I can increase it slightly. I want about 2 volts on there. Not more than that. 2 because it makes it more stable, but not much more because I don't want to overdrive this thing. So what is that? There's, well, just about 2 volts. There's about 2 volts. That's 2 volts over there. Doesn't matter, just keep it low. And now I'm going to start tweaking, and I'm going to start with the with number 24, which is the top of the second IF transformer. Now some of these, they're still filled with wax, so I'm going to go in here and see if I can't break the wax with, first of all, with a metal screwdriver, just to get through. Once I'm through, I use the ceramic screwdriver because I don't want to break the cores. I'm just going to put this on dummy load. Where is it? The other way. That's about a peak. There's my peak. Okay, that one's done. Now I'm going to number 18, which is the top of the first IF. Again, I've got to get through all this wax. I think I got it. Oh, wrong way. Ooh, that's nice. Whoa! That's really nice. That's a huge change. This is a very weak signal going in, so that's a huge difference. In fact, something's wrong here. When I touch ground, this signal is far too strong. I'm going to have to make it go through the switchable attenuator that I've got. Otherwise it's far too strong and the AGC keeps kicking in. So now I can put different attenuations on here. Give it a decent signal there. It's too much attenuation. How about that? Well, let's get onto this load. Yep, okay. Let's try now. Bloody hell. I've got attenuated some more. Wrong way. Okay. Here's my peak. That was a huge increase. Huge, and I don't understand why, because it was actually waxed in. The whole thing was waxed in. Let me go to the bottom one now. See if we get the same thing. Once again, I have to break the wax. It's sometimes not that easy. When I put the screwdriver in, it's the metal one to break the wax, so it can change that somewhat. I'm not too worried about it. Okay, I've got it. Now I'll put in the other one. Wrong way. There's my peak. Done. Done. Okay. Now I'm going to go to the one on the actual can. And this is a real bummer to get to. Okay, I've got it, I think. Wrong way. Okay, that's my peak. Now what happens here is, because I'm close to the top here, you get close to that light decoupling and you can actually change it. So you've got to be careful. The exact values are not important. It's when you're standing still and you can adjust it and you see the relative change in there. Let me try the top one. That's about peaked. That was fine. That one was just right. Okay, now to do the last one, I'm going to show you the scope. As I mentioned, the last one, the last call, I prefer to do visually. So here we are. We've got a 10.7 megahertz carrier. We've got modulation. It's FM modulation, about 20 kilohertz deviation. Could be less, could be more. I'm sending a 600 hertz tone, and it's coming out here, going into that lightly coupled connection to the ECC85. Now if I put the volume up, you can hear it, and you can see it. It's actually looking pretty good. Put this on dummy load so we don't have to hear it. There's the volume adjustment. Now, I don't really think that needs adjustment. But let me try it. Let me just see something else here. If I put FFT, what I've got here is the fundamental 600 hertz. I've got no distortion whatsoever. Now let me try, see if I can show you the effect of this. See, it's actually distorting the wave. If I go too far, it's distorting again. You can see the wave is actually distorting. So actually it was, oh, when I pull it out, the whole thing comes out. There we go. That is perfectly aligned. This thing is perfectly aligned. You see a perfect sine wave, and if you had a better FFT function, you could see there's no distortion, just the fundamental. So we've got that thing perfectly aligned. That's all it takes. It doesn't always work out this well, but it just happens to be in perfect sync. Right, let's get on with the next thing I want to show you. The maximum frequency that this thing can tune to is about 101. I'm not sure exactly what it is, but there's the end of the dial. Now, I want to go as high as 101.6, which is where one of my favorite stations is. So let me put it where it's comfortable to still adjust slightly. So I'll go slightly to the left. I'll go there. Okay. And then I've got my signal generator function on the iPad operating, sending a 500 kilohertz tone. Okay, that's the tones coming out as audio. And I've got my little transmitter here. This is one of those radio transmitters where you send signals from your phone to your car. It's basically a small little FM transmitter. It's actually stereo. And I'm going to put the volume up where I left this on the dial. And I'm going to see which frequency this tone comes through. I think it's there. I can hear the carrier. Give it a tone. There it is. You can hear it very, very well. Now, that means that my top of the dial is actually at 100.7. I'm not far off. I want 101.6. Okay, exactly where I have that. If I tune off, if I tune slightly to the left, slightly to the right, I can still pick up the tone and lose it at the other end. So I've got a little bit of span there. Now what I want to do is I want this thing to be set to 101.6 and I want to get that signal. So what I'm going to do is I'm going to put it at 101.6. In fact, I'm going to give it a bit more, 101.7, okay? So now I can hear it. I've got the speaker on, and I'm going to adjust this. In fact, what I'm going to do, I'm not going to do it all at once. I'm going to set it back to where it was. Whoa. That's where it was, right? 101.7. I'm going to shift it to 101.9 where I can still sort of hear it. There it is. When I take it away, it moves a bit, but I can still hear it. 101.1. The fact that I'm putting pressure on that cap and my hand is close, affects it, you see. So it actually is now set it to 101.2 because I've just clicked it to 101.2, 101.4, .6. Tune it again. And what have I done? If I take it away, this is actually now, I've just adjusted this to 101.7 and it's perfect. There's 101.8, it loses it. So now, if I tune the dial, there's my 101.7. So if I put the transmitter at 101.6, I go back slightly. There it is. Perfect. Perfect. I've just extended the dial to 101.6. Okay. And if I put an antenna in, I should get my radio station, and we'll test that now. But I still want to see what's happened to the lower end of the scale, because there's a station on 88 megahertz, and I want to make sure that I haven't lost that one. Let me just test for the 101.6 station. Yep, there it is. And I can actually go through it. Perfect. Let's look at the bottom end of the scale now. As I said, there's one on 88.0 and I don't want to lose that. There it is. I haven't lost it. Perfect. This thing is receiving very well, but it's playing a lot of music, so I can't really show you. Brilliant. So what have we achieved here today? Well, we've aligned the FM, the cores aligned for peak reception, as well as the one for the best slope, so we get less distortion. That's come out pretty well. A huge increase on one of these cores. And I don't understand it because it didn't seem to have been tampered with. The wax was still there, but it seems to have needed adjustment. Don't ask me why, but it was a huge change. And the other thing I've done is I've stretched the dial somewhat so that I can still get the lowest station that I'm interested in, which in my case is 88 megahertz. And the one that I want at the top at 101.6, I can get it comfortably on the dial now. It does mean that my dial pointer is now a little bit out for the other channels, the other stations, but quite frankly, we've got 4 or 5 that I receive here where I live, and I know more or less where they are, so I don't really care that the stations aren't exactly where they're supposed to be. I'm more interested in having made this a lot more useful for me by extending the top end. So that's where I'm going to leave it for today. I've got quite a lot of work to do on the cabinet restoration and cleaning. And so I think I'll come back with the final video and then put this all together, show you the result of that work, put this all together and do a final test. The sound of this thing, as it is now on FM, especially when music's playing, which unfortunately I can't show you because of copyright reasons, is amazing. It's amazing on my workshop speakers. I want to see what it sounds like with the actual speaker and it's in the cabinet itself. The two, in fact, the tweeter as well. So this is it for now, and I hope you've enjoyed this video, and if you have, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching, bye for now, and stay safe.